Okay, in the last segment, we asked the question, what do you do to find the inverse transform of a fraction that has a quadratic denominator that will not factor? And we said, well, you can complete the square. But now, what if you have a quadratic denominator that does factor? Well, the answer is that you split this into two fractions using the technique known as partial fractions, which you undoubtedly learned in calculus, but occasionally we need a little reminder, so I'll do one or two of these to remind you how that goes. If these are just linear factors down here to the first power, then you simply write this under the assumption you can split it into two fractions. One has the one factor, the other one has the other, and you give the, these are going to be, now we're starting with a proper fraction. This has degree 0 and this has degree 2. So we should be able to split it into proper fractions. This has degree 1, so that has to have degree 0, which is constant, and I intended to put a b there. Okay, now the trick is you just put this back together by getting the common denominator. Here you'd multiply up and down by s plus 4. And here you multiply up and down by s minus 1. Now, these two fractions are equal and they have the same denominator, so they must have the same numerator. Therefore, 20 is equal to a times s plus 4 plus b times s minus 1. Now, there's a few ways you can do these. One of the common ways is to multiply all this out and gather it up and get a system of equations. The coefficient on s over on the left-hand side is 0. So people who do it that way would say a plus b is equal to 0, and then 4a minus b is equal to 20. System of equations, you can solve it fairly quickly. That works, and there's nothing wrong with it mathematically, except this, it's inefficient. So let me show you a better way, I think. With something this simple, what I'm going to do is set s equal to 1. Now, when I set s equal to 1, we get b times 0 here, so the b term drops out entirely. And on the left side, I still have 20. Setting s equal to 1, I have a times 2. So a must be equal to 10, and I get that number quite rapidly. In the same way, I can set s equal to minus 4, and when I do that, I've got 0 appearing here. Minus 4 minus 1 is minus 5, so 20 equals minus 5b, and therefore b must be equal to negative 4. And so that tells me that my I missed it. I wanted the inverse transform. The inverse transform of 20 over s minus 1 s plus 4 is equal to the inverse transform of, well, we split it into the two fractions now. A is 10, so that's 10 over s minus 1 plus the inverse transform of negative 4 over s. Now that's s plus 4, but in the table it's like so. S minus a minus 4. Okay, now if you don't have them memorized, you look this up, and that's an exponential form. Well, I seem to have lost the other page of my table. Yet another good reason to memorize your forms. But anyway, 1 over s minus a is e to the, will transform, inverse transform back to e to the at. So if you have a s minus 1, this goes back to e to the 1t. If you have s plus 4, that goes to e to the minus 4t. So that 10 just goes along for the ride. E to the t minus 4 times e to the minus 4t. And there we have our inverse transform, and we've done that by splitting this into two fractions with the technique of partial fractions.